Hey everyone, today we are solving LeetCode problem 1155, number of dice, rolls with target sum. In this problem we are given n dice and each die is having k faces number from 1 to k. So we are given 3 integers, number of dice, number of faces on die along with the values. Let's say this die is going to have value from 1 to 6 and the target sum. The target value we have to achieve. Now we have 2 dice. How many possible combination can we have? Let's say on the first die 1, die 2. First die I'm getting 1. On the second, if I get 6, I will get the target sum 7. Now 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. These are the possible combinations. The constraint given to us is that n and k value will go up to 30 and the target sum can go till 1000. Okay, so how do we approach this problem? We can straight away use one die at a time. Let's say in the starting die is 2 and the target we have to achieve is 7 and our k is 6. 6 means number of faces on each die. Let's say we first roll the first die. 1, 2, 3, 4, 5, 6. We get 6 possibility. 1, 2, 3, 4, 5, 6. Now at this level, number of die is reduced to 1 and target sum for each call is reduced to 6. Now we got 1 from first die and from the next dies we have to achieve 6. Remaining target is 5, 4, 3, 2, 1. This is our remaining target. And as we are left with one die, so this die will roll again. And if I roll after 1 on the first die, we'll get 6 possible combination. 1, 2, 3, 4, 5, 6. Now at this level, our number of dice are 0. So we cannot move further. We have to check on this level only. If I get 1 on the second dice, our remaining target is 5. So if we check for 6, our remaining target is 0. So for these target equal to 4, 3, 2, 1, 0. So here at this position, our number of dice are 0 and target sum is 0. So this is one possible answer to us, that on the first die we get 1 and on the second die we get 6. So let's check for 2. 1, 2, 3, 4, 5, 6. In case of 2, if we get 2 on this position or 1 on this position, our remaining target is 4, 3, 2, 1 and here target is 0. So at 5 our target is 0 and number of dice are already 0. So 2 and 5 are our second answer. 2, 5. This is going to be our second answer. Let's try to write a pseudo code for that. We have solve function, number of dice, target. N is our number of dice, T is our target. So we will check if n equal to 0. Let's say we have used all the dice. If target is equal to 0, it means we can return 1. This is one possible answer. Else we can directly return 0. So this is our base case. Otherwise what we will do is I equal to I equal to 1, I less than equal to 6, I plus plus. I'm considering this example only. So this is our k. I plus plus. I'm making further call to solve function where n with n minus 1 we have used 1 dice and target is reduced to target minus I. So this is my recursive call in the solve function. And the solve function is going to return integer array, which is our answer. So we will also capture our answer. Int answer equal to 0, answer plus equal to the solve function call, and in the end we can return answer. So here what we can do further, we can also add one call. If target at any position gets less than 0, we can directly return from 0 from that call. That call is not going to lead to our answer because we have dice values from 1 to 6 or 1 to k, which is positive. So we cannot achieve negative target for that. Okay, so this is going to be our function call. This is a native recursion I have written here. But let's say we have n equal to 3, k is 6 only, and target is equal to 7. Let's say on the first die we got 1, and in our second call we got 2, where n is equal to 2 is remaining. And on the second die we got 2 from here, 1 from here. After that 1 die is remaining, and from that 1 die we will check whether we can achieve 4 or not, because if we get 4 we will get our answer. Here also we will check whether we can get 4 or not. If we get 4 we get our answer. So this is our overlapping subproblem, that we are left with n equal to 1 and want to achieve target of 4. This is our requirement. Here we checked whether we can achieve 4 with 1 dice. Here also we achieved whether we checked whether we can achieve 4 with 1 dice. So these are our overlapping subproblems. So to overcome these overlapping subproblems, what do? We generally do the memorization. That for this condition we will memorize our answer. We have n value as well as target value. So target value will go from 0 to target, and n value can go from 0 to n. So I'm going to take a DP array of n plus 1 size and target plus 1 size. So whenever we compute our answer, we are going to store in this DP. So here we stored in our DP that DP of 1 with target 4 is equal to that we have one way. So we will not directly compute it. At this position we will get to know we have n equal to 1, and target equal to 4. We can directly return 1 by checking our DP array. If the value is too large, so it is going to overcome a lot of overlapping subproblems. Apart from that, we are also asked that we have to take modulo of answer with 10 to the power 9 plus 7. So we will do in one answer. So this was our recursion code. This is our computation. So before computation, we will check whether we can whether we have already computed our answer or not. And while returning from answer, we will store it in our DP of n and target value of that respective call. Okay, let's try to write the code. You'll get more understanding from there. Let me just straight away write the solve function where I'm getting number of dice, faces on each dice, and target value that we have to achieve. I will return total number of ways to achieve the target. Private integer sol int n int k int target. First of all, I will see whether I have utilized all the dice or not. N equal to 0, it means if target equal to 0, we can return 1, else we have to return 0 because we are left with 0 dice. Now let's say I'm utilizing that current die and capturing answer from each call. Answer equal to 0 for each value of I equal to 1 to I less than equal to k, I plus plus. I'm rolling the die and getting I value. It means dice is reduced by 1 k, and target is also reduced by I value. Answer plus equal to, and we can return answer. Let's test our sample test cases. The bigger test case I have removed. On the smaller test cases it is working fine. If I add that test case 30, 30, 500, it will give me TLE because we are having overlapping subproblems. Along with that, I also need to take modulo. Int m equal to 10 power 9 plus 7 and take modulo from here. Divide equal to m. Now we are also taking the modulo. I'm running again so that you can see that we are getting TLE. Modulo equal to, there should not be a space. Okay, now we are left with one task that we have to memorize the solution. Memorize values for every remaining number of dice and target value. So for that, I need to take a DP array of 2D size. One for rows will represent n, and a column will represent target. DP, here DP is equal to new. I'm taking integer value so that I can store null value as well, because a small primitive integer array is initialized with 0, and 0 can be our answer. So I'm taking integer of n plus 1, target plus 1. Now my DP array is initialized. I'm storing in this DP for n and k the answer. But before this, I will also check whether this value is already pre-computed or not. If DP of n and target is not equal to null, it means we have already solved it, and we can directly return this value. Before that, we can also add one check to do some kind of pruning, that if target value is less than 0, do we need to proceed ahead? No, we can just directly return 0. Now we have added memorization. Let's test now. Now we are not getting any TLE. Let me submit this problem. Submitted successfully. Hope you understood the problem. Thank you guys. If you have any doubt or any concern, you can comment down below.